JUNO, US space probe that is designed to orbit Jupiter. JUNO was launched by an Atlas V rocket from Cape Canaveral, Florida on August 5, 2011. On October 9, 2013, it flew by Earth for a gravity boost on its journey to Jupiter, where it arrived on July 4, 2016. JUNO orbits Jupiter every 11 days in a highly elliptical orbit over the planet's poles. Unlike previous probes to the outer solar system, JUNO is solar powered. It is the first explorer to peer below the planet's dense clouds to answer questions about the gas giant itself and the origins of our solar system. Now, in an extended mission phase, the agency's most distant planetary orbiter continues its investigation. At the time of JUNO's closest approach to Ganymede, during the mission's 34th trip around Jupiter, the spacecraft was within 645 miles of Ganymede's surface and traveling at a relative velocity of 41,600 miles per hour. JUNO's WAVES instrument, which tunes into electric and magnetic radio waves produced in Jupiter's magnetosphere, collected the data. Scientists then shifted the frequency into the audio range to make the audio track. JUNO data indicate that a change in the gas giant's magnetic field has occurred during the spacecraft's 5-year orbit. The Great Blue Spot is drifting eastward at a speed of about 2 inches per second relative to the rest of Jupiter's interior. At the rate, the Great Blue Spot should lap the planet in about 350 years. In contrast, the Great Red Spot, the long-lived atmospheric anticyclone just south of Jupiter's equator, is drifting westward at a relatively rapid clip. Lapping the planet is only about 4.5 years. The simplified model of Jupiter's pole shows the geometric patterns of vertices like those observed on Jupiter spontaneously emerge and survive forever. This means that the basic geometrical configuration of the planet allows these intriguing structures to form. Although Jupiter's energy system is on a scale much larger than Earth's, understanding the dynamics of the Jovian atmosphere could help us understand the physical mechanisms at play on our own planet. During the Prime mission's 35 orbit of Jupiter, JUNO collected more than 3 terabits of science data and provided dazzling views of Jupiter and its satellites, all processed by citizen scientists with NASA's first ever camera dedicated to public outreach. JUNO's many discoveries have changed our view of Jupiter's atmosphere and interior, revealing an atmospheric weather layer that extends far beyond its water clouds and a deep interior with a dilute heavy element core. Near the end of the Prime mission, as the spacecraft's orbit evolved, flybys of the moon Ganymede initiated JUNO's transition into a full Jovian system explorer. Now, in its extended mission, JUNO will continue its investigation of the solar system's large planet through September 2025 or until the spacecraft's end of life. This extension tasks JUNO with becoming an explorer of the full Jovian system, Jupiter and its rings and moons, with additional rendezvous planned of 2 of Jupiter's most intriguing moons, Europa and Io. JUNO is scheduled to orbit at Jupiter for about 20 months. The spacecraft likely can't keep going much longer than that because the intense radiation environment at Jupiter. JUNO has gone farther into deep space than any other solar-powered probe. The spacecraft set the record in January when it was about 493 miles from the Sun, surpassing the distance of the European Space Agency's Rosetta spacecraft during the latter's journey to Comet 67P, Churyumov-Gerasimenko. JUNO spins to stay stable, a strategy that borrows from the design of NASA's old Pioneer probes. The end of its mission, JUNO will perform a 5.5-day maneuver that will crash it into Jupiter's atmosphere intentional.